Hey everyone, this is a demonstration of epiPath's capabilities of working with whole slide imaging data right here in the web browser. The URL to the web application is the same as it was, episphere.github.io/path. This will again be available as a link in the video description for you to click and follow along if you'd like to. When you do, you'll see an interface like this. We need to log into Box so that we can interact with the imaging data we've stored on there. I've already logged in, so it sends me straight to that screen. And once I do, we can see that the application recognizes me, shows me the folders and files I have in my root folder, and pre-selects a dataset for me. Now this might not be the case for you. You might have to select one from the list of available datasets in this drop-down. Or if you don't, if this is perchance your first time using epiPath, you might want to click on the three dots icon against the folder housing your images, select users dataset, and epiPath will automatically set up all the configuration it needs to use that folder as a dataset. Now that mine is selected, I can go into annotations and we can see that it is asking me to select an image so that it can show us the annotations I made for it. So let's select this one maybe. And we can see that the interface changes a little bit. This is because whole slide images are rendered in a different viewer. And the reason for that is that these files are generally quite sizable. They're of the order of hundreds of megabytes or even multiple gigabytes. And pulling them into the browser entirely is not feasible, so we load them in specific chunks called tiles in pathology speak. We saw that the image was rendered in squares, and these tiles are stitched together to show us the entire image. This is done using the ImageBox tile server, linked to the paper in the description. And once the image is loaded in, we can just do the operations we are used to. Scroll to zoom in, pan just by dragging our mouse, scroll back to zoom out, and there's these options. So if I wanted to zoom out all the way, I click on the home button. If I wanted to look at this image in full screen, I click on this button right here and we enter full screen mode, and the same operations work even in full screen mode. I'll click on it again to zoom out, to go back I mean. And yeah, we can see that the tiles are loaded in. The image is loaded in higher resolution once I zoom in. And going into annotations, I have the definition that I created beforehand, and we can see that we have two options now here. The pencil option is the annotations that I created on this image. So anytime I create an annotation on a certain area, it will show up here, and the microchip looking thing will show me the model predictions that were made on this image. So let's in fact try that out. I think maybe this area should be good. So yeah, I think this is my region of interest. I zoom in there and I click on the second option on the top left, and we can see I have two choices. I can either run the model on the entire image or on the visible region, the region of the image that I'm seeing right now. Running the model on the entire image does take up a bit of time, because remember, the model is running on your machine, and it might take a couple of hours to look at an image this size. So let's try running the model on the visible region, and yeah, we can see the blue outline is the section of the image that the model is looking at, and these tiles are the sections of the image that the model is analyzing at the moment. Once it's done with those, which it was, yeah, it moves on to the next tiles, and the size of these tiles is determined by the magnification I was at when I started the model. Once it's done with those, which it was, we can see that the tile magnification reduced, or the tile size reduced. The model is looking at the image at a higher magnification now, and we can see the predictions start to come in. Now the reason that I wasn't able to see any predictions at the earlier tile size was because my prediction zoom level is set at 30x, so only tiles at this zoom level will have their predictions visible on the image. If I were to select 20x, I guess all of those were absent. So if I go into show predictions for and click on deselect, in fact, the absent button, we can see that all those tiles were marked as absent by the model. If I enable it again, and now again the tile size reduced, the magnification increased. In other words, if I click on 40x, we should see some tiles being predicted for at this magnification, and yeah, we can see the predictions coming in. We can stop the model now. If I click on the cog, click on stop model, it will stop the model. Just it will look at all the tiles it was looking at, and just stop processing. So we have these predictions. Again, let's see how many were absent. yeah, there's quite a few absent here. And this model does only classifies for presence or absence. Uncertainty is something that the model will have in future iterations. Now that we have these styles, maybe we can see if the model was right perhaps. No, I think I'm not sure that the model was particularly good. So uh, I would, if I want to improve the model, I have to give it more training data. And the way I would do that is by clicking on a tile I disagree with. I clicked on it and it shows me what the score was, what the prediction was, and I feel that this tile is not perhaps the right prediction. I can go in and click on this button right here. I rejected the model's predictions. And maybe if I looked at something else, yeah, perhaps I think I agree that this is absent. There are no points of interest that I want to be looking at here. I agree with the model's predictions here. And what I'm doing here is I'm creating a new training data set for a newer iteration of the model to be trained on. Now, because I'm essentially giving feedback to the model on whether its predictions were right or wrong, I can use that feedback to create a new data set out of these styles to show the model what its failures were and what its successes were, and build on the successes and learn from its failures. In that sense, this is enabling active learning, which is one of the ways of training deep learning models. It is to sort of iteratively give it more training data and let it learn from its previous decisions. Just to see all the predictions that we had, this can be done, of course, at any level. If I click on this, I mean, this seems about right to me. There's nothing there that I want the model to be predicting on. And this one as well, I guess I can mark as good. And I just mark enough tiles, I provide enough feedback for tiles that I feel is enough to train the newer iteration of the model. Another option that might be of interest is the transparency. Now perhaps we have both present and absent right here, so it's a little hard to see where the present predictions are, so we can click on the show predictions for button and reduce the transparency of the absent predictions. So the present ones are a little more visible. We can of course make this all the way go all the way up. We can change the color of the present predictions maybe, so they are better visible. And yeah, this is again up to you, up to the user to set it at the level that they feel comfortable at. And yeah, these options should allow faster annotation of the image, since you don't have to look for a specific section. And if a section of the image was already analyzed by someone else, as long as you have the same image and the same model, which you should if you have the same data set, you will be able to automatically get those analyses for free and just start giving your own feedback on those images. So yeah, this should enable faster training and faster active learning, and thus lead to more performant models. That was it. I think if you have any issues or any questions, please feel free to hit us up on our GitHub channel right here. This is a public conversation channel that we have for this tool. If you have any problems that you're facing, maybe you can open up an issue on GitHub. This allows us to look at what people are doing and what bugs there are, if we haven't found those ourselves. And yeah, the code is of course open source on GitHub right here, so you should be able to look at what we are doing, the updates that we made to the code, and all that good stuff. And thank you so much.